Welcome to Homework Lib.
Hi, over here we're going to have a weak base, which is going to have a kb equal to 1.6 times 10 to the minus 6. And with this, we want to calculate the pH of a solution of such weak base with concentration 0.0012 molar. In this case, I'm going to label our weak base as A minus, just for using that as reference into our solutions. Well, actually, let's use B minus, just to overstate that this is going to be a base. So the reaction of this base with water is going to produce Hb plus the OH minus ion. And this is going to be the Kb, the basicity constant reaction. So if we write down our ice table, what we're going to get is that the initial concentration of the weak base is going to change by a certain amount x that would get dissociated. Water doesn't enter equilibrium because it is going to be a condensed phase. So we're going to add plus x on both of these quantities, and of b minus, we're going to get 0.0012 minus x, x, and x. So with this, our Kb would be equal to the concentration of Hb times the concentration of OH minus that we're going to get in solution, divided by the concentration of B minus. Replacing the values that we get at equilibrium, this becomes x squared divided by 0.0012 minus x. So over here, taking advantage of the fact that Kb is equal to 1.6 times 10 to the minus 6, which means that a very small amount is going to dissociate, what we can do is something called the small x approximation, in which the initial concentration minus x is going to be essentially the initial concentration. So with this value approximates to x squared divided by 0.0012. Thus, solving for x, which is going to be equal to the concentration of OH minus that we're going to get at equilibrium according to our ice table. Let's emphasize that this is the value of the concentration at equilibrium. It would be equal to the square root of Kb times 0.0012. Plugging in the value of Kb, we're going to get that this is equal to 4.4 times 10 to the minus 5. Now, to calculate the pH, we're going to go through the pOH, which is minus the logarithm of the concentration of OH minus, so minus the logarithm of this value, which rounds up to 4.36. And now we're going to take advantage on the fact that pH plus pOH is going to be equal to 14, giving us that pH is 14 minus pOH, which is 14 minus 4.36, giving us a value for pH of 9.64. And this is going to be our final answer. And with that, it would be all. Thank you very much and have a good one.